Electrical energy is a common form that is converted to many other forms and does work in a wide range of practical situations. Fuels such as gasoline and food carry chemical energy that can be transferred to a system through oxidation. Chemical fuel can also produce electrical energy, such as in batteries. Batteries can in turn produce light, which is a very pure form of energy. Most energy sources on Earth are in fact stored energy from the energy we receive from the sun. We sometimes refer to this as radiant energy or electromagnetic radiation, which includes visible light, infrared and ultraviolet radiation. Nuclear energy comes from processes that convert measurable amounts of mass into nuclear energy. Nuclear energy is transformed into the energy of sunlight, into electrical energy in power plants, and in the energy of the heat transfer and blast in weapons. Atoms and molecules inside all objects are in random motion. This internal mechanical energy from the random motions is called thermal energy because it is related to the temperature of the object. These and all the other forms of energy can be converted into one another and can do work. Gobble down 5 bananas and you will have enough energy to swim for about an hour. That is because your body is a complex machine capable of turning one kind of energy, food, into another kind, movement. Using a certain amount of energy-rich fuel, a car can transport you a certain distance down the road. What we have here are 2 examples of machines, the human body and the automobile, that obey one of the most important laws of physics, the conservation of energy. Written in its simplest forms, it says that you cannot create or destroy energy, but you can convert it from one form into another. Pretty much everything that happens in the universe obeys this fundamental law. The law of conservation of energy and the idea of a closed system sounds a bit abstract, but it becomes an awful lot clearer when we take a look at this PhET simulation. In this simulation, falling water turns the wheel. As the electrical generator is attached to the wheel, mechanical energy is converted into electrical energy. This energy is then applied to the heater to boil water, resulting in conversion of electrical energy into thermal energy. Note that there is some loss of energy at each of the steps of conversion. In this case, the steam generated as a result of the boiling water is used to rotate the wheel. Thermal energy is converted into mechanical energy. This mechanical energy is used to generate electrical energy, which in turn is used to drive the fan. Solar energy is converted into electrical energy. As the sky becomes cloudy, solar cell does not receive any energy. Clearing of the clouds results in enough energy supplied to the bulb. Chemical energy as a result of eating food stored in the cyclist is used to ride a cycle. This energy is converted into electrical energy with the help of a generator to light the bulb. The law of conservation of energy is completely different from energy conservation. Energy conservation means saving energy through things such as using energy efficient cars or using public transportation. Generally, it helps you save money and helps the planet. The law of conservation of energy has nothing to do with saving energy. It is all about where energy comes from and where it goes. Take this challenge. A person with a bag on his bike has a total mass of 98 kilograms. If you neglect air resistance and rolling resistance, how much energy is required to accelerate from rest to 1 meters per second on a straight, flat road? We discussed about the nature of work and how it is related to energy. Different forms of energy and the law of conservation of energy was also discussed.